This passage is a research passage. We know it's research because we see experiment 1, experiment 2, experiment 3, and a brief summary of what they did. So with research passages, remember, we're going to read, research, read, remember the R's, but not carefully. We're just looking for the process and the differences between the studies. So in this one, it looks like the students had a flask that filled to the top with water or salt water at 20 degrees Celsius. And then in experiment 1, it slowly heated until it gets 100 degrees Celsius, which is boiling. Water and steam come out the top. Okay, experiment 2, looks like they submerge it in a cold bath. In experiment 3, 2 different saltwater solutions were prepared. Looks like one has a lower salt content than the other. That's it. So they're really just seeing what's the effect of salt water on temperature, seems like. R and R approach the questions, read and then reread. We're going to be doing the rereading together, breaking it down step by step. Question 35, we have this nice little diagram that's explained here. It says the water on the top is 10, the water on bottom is 80 degrees Celsius. And it says if the barrier separating the two compartments, this barrier, were removed without disturbing the water, what mixing, if any, would occur? So this is really a lot of this passage is about this, right? And if we look at the answer choices, we're talking about the density of water. Is it more dense or less dense when it's cold or warm? This is a little bit of knowledge, but you may also just know it. Colder water is more dense. Think about the water in a swimming pool. It's colder at the bottom, so the cold water is more dense. It stays at the bottom. So we're going to eliminate choice B and C. The upper part is less dense. That's not true. And the lower part is more dense. That's not true. So since the colder water is at the top, it's more dense. It will mix and fall to the bottom. So your answer has to be D. A little bit of knowledge, a little bit of critical thinking. Number 36, based on the results of experiments 1 and 3, 1 liter of distilled water and which of the following quantities of NaCl added to it would most likely boil at the lowest temperature? Well, it's kind of interesting because we see salt, but not NaCl, but you have to know that NaCl is salt. That's the scientific name for it. If you don't, it's actually in the reading, so you can see that. So we're just going to say, which does water boil faster when it has salt or when it has less salt? And it tells us solution 1 had a lower salt concentration and solution 1 boiled at a lower temperature. Right? So lower salt content corresponds to lower boiling point. So we want to add the least amount of salt possible. So F. Number 37, we're using experiment 2, which of the following graphs shows how the volume of liquid changed with temperature. So it says as the temperature of the water apparatus decreased, the height of the water in the tubing decreased. Don't be tricked by this -6 degrees Celsius. That's the temperature of the cold bath, right? We don't see the bath temperature. We just see the water temperature. So we're looking for an initial decrease, which we see in choice B and D. And at 4 degrees, the height of the water temperature stopped decreasing and then began to increase. So that happens only in choice B. So your answer is choice B. This is just reading and putting the reading to the graph. Number 38, which of the following changes in procedure of experiment 3 would have provided the most information about the effect of decreasing temperature? So we're using experiment 3. In experiment 3, they said they cooled as in experiment 2. In experiment 2, they put it in a cold bath of -6. So that's what's happening. So what are we going to do? If we want to test the effect of decreasing temperature, we also need a lower temperature, right? No freezing occurred, so we might want to get a lower temperature. See what happens if we can get some freezing. So let's just go with the easy, obvious answer. We're testing an effect of decreasing temperature. Let's decrease the temperature, choice F. Number 39 is a suppose question again. It's a suppose if Y question. It's a key to say you're going to have to do some critical thinking. So suppose that equal volumes of solutions 1 and 2 from experiment 3 were mixed with the resulting solutions and tested as in experiment 1. So we're using experiment 1 and 3. salt water would most likely have squirted out of the top when the temperature was. So experiment 1, they're gonna boil the water. We're gonna see when it comes out. We want to see when's that gonna happen. In experiment 3, we know they mixed solutions 1 and 2, or they had solutions 1 and 2. One had a lower salt concentration, the other had a higher salt concentration. And we want to basically know when does it boil. So solution 1 boiled at 102, solution 2 boiled at 104. So you mix them, it's going to be between 102 and 104. C. Number 40, we're using experiment 2. As the height of the water in the glass tubing decreased, which of the following properties changed? Okay, so we're going to go start with volume, but we look and see that volume changes in all of them. So we already know volume changes. And mass, okay, well, mass is an interesting one because the temperature is decreasing, which means we're not losing any water to evaporation. None of it's squirting out the tube, none of it's boiling away. So the mass doesn't change, as the volume of water also doesn't change. Those two would be connected, right? And so we're going to eliminate 2. Density, we know density changes as water heats and cools. That's actually been a main focus of the passage. It's also a piece of knowledge you might just have. So choice H, 1 and 3. Reach out if you have any questions about this passage.